Hello, my name's Omar, and I am doing the Fibonacci sequence PBL2. The driving question is, what is the mystery of the Fibonacci sequence? The Fibonacci sequence is introduced to the West by Leonardo Fibonacci and was published in his book Liber Abaci. The book advocated numeration of the digits 0 to 9 and place value. The Fibonacci number sequence was known to Indian mathematicians as early as the 6th century. In the sequence, each number is the sum of the previous two numbers, so 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, 233, 377, and onwards. This sequence appears countless times in nature, for example in pine cones. The number of spirals on a pine cone will almost always be a Fibonacci number, and so will a pineapple, artichoke, cactus fruits, cauliflower, daisies, sunflower, leaf placement on stalks, trees, and even population growth. Humans even have Fibonacci numbers in them. Not including the thumbs, we have 8 fingers in total, 5 digits on each hand, 3 bones in each fingers, 2 bones in one thumb, and 1 thumb on each hand, and that's just in our hands. In plants, the Fibonacci sequence provides the optimal way for their leaves to catch sunlight. The leaves are at angles to each other, and if they were each 180 degrees to each other, they'd overlap after one rotation. This would happen with every degree of a circle, even if you were to use fractions. For example, rational fractions, after a certain number of rotations, the pattern would close and the leaves completely overlap, so plan to use the Fibonacci sequence and phi, or the golden ratio. Phi is greater than 1, but less than 2, but greater than 3 over 2, but less than 5 over 3, but greater than 8 over 5, but less than 13 over 8, but greater than 21 over 13, and so on. With each number getting close to 1.61833988875 to infinity, because phi is irrational. But yeah, that's phi's actual value. If you were a plant, you'd place your leaf anywhere, and then figure out where to put the next one by dividing 360 degrees by phi. You'd get around 222.5 degrees. New leaves tend to pop up in the spaces left behind by old leaves, but never fills things in evenly, so there is space for a new leaf. The Fibonacci sequence can also be used to find out the growth of, say, rabbits. If you were to start out with 2 rabbits, and they were to make another rabbit, and that rabbit was a female, the next generation, the total population would be 5. And then the next generation, the total population will be 8, and the next one 13, and the next one 21, till forever, basically. The Fibonacci sequence can also be used in shells to create the perfect spiral. If you had a square that was, say, 1 centimeter by 1 centimeter, you put another one on top of it, and then the length of both of those squares, put another one that was like that, so 2 by 2 next to it, and then length of those ones, 3 by 3, then 5 by 5, 8 by 8, 13 by 13, 21 by 21, and so forth. You get a perfect spiral. The Fibonacci sequence seems too perfect to be real, but in reality, it'd actually be a lot stranger if the sequence did not show up in nature.